The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hello, and welcome to SkyTour livestream once again. It is I, Mark D'Antonio. Nice to see you guys here. Daryl's taking the night off, and we have a bunch of folks out here ready to watch this fantastic thing that happens in the night sky. It's called an occultation, where the moon is passing in front of a much more distant star, Spica, which is this star right here. Spica is a very bright star in the constellation Virgo. Let's go into our planetarium to show you. Here's Spica, right? And if we center on Spica, you can see that Spica is a star that is a pretty hot star. It's a star that's a B1, which is there's on the scale OBAFGKM, and it's a B1, so it's actually really hot. Kind of just after the O9s. The O stars are the hottest and bluest stars in the entire sky. And this one is a B1, and then it's actually a normal hydrogen fusing star. But it's massive, it's hot, and it's probably going to end its life as a supernova. We'd have to check its exact characteristics. That vertical line you see here, I'm going to get rid of that in a second. So let me just take care of that. We have we only have a few minutes until the occultation begins. So you're going to see Spica go behind the moon here. And then it takes about an hour or so, and then it comes out the other side. So we're going to stick with you the whole time. And we'll talk. If you guys have questions, we'll take them. Looking forward to it. But it's 10:42 p.m. here. And at around 10:48 or so, it should go behind the moon. I want to try and show you the other side. As you can see up here, it's actually pretty bright in the observatory right now. So it's a bright sky. So let's see if we can actually pull out the dark side, the side that's unlit on the moon right now. And you can kind of barely see it starting around here. Spica's getting close. Let me see if I can bring this up and drag that out a little more. Yeah, this is obviously, we want to not do that. That's kind of a weird shot. But we would much rather not do that if we could avoid it. Because the sky is so bright. That's the problem that we're facing right now. So I will bring this down to a more reasonable amount. That was the problem given from the very beginning, was that the moon was going to be in still a twilight sky over here like you see. So it was going to be kind of hard to capture the sky and the unlit side of the moon while the sky is still blue out there. As you can see, it's still blue. But to get what we see here, that's actually quite an achievement to be able to see Spica in that daytime sky, twilight sky, next to the moon like this, where the moon isn't blown out completely and we can still see Spica. Now, we could punch it up just a little, like this. This part's blown out a little, but we can see the terminator. You can kind of see it's moving around. We're going to just watch Spica. I'm going to zoom in. And we'll be zoomed into this segment of the moon here. And we have a few minutes before it should be going behind the moon. And we'll watch. And this is live, by the way. And our camera frames are going by at 2.6 milliseconds. So we should be able to see everything going on. And if I increase it at all, what happens is we get a little bit of an addition to the light, but it's really kind of hard. You still can't see, because this is the unlit side of the moon is still mixing with the blue sky, so it's kind of hard to see it. I think what we're going to end up seeing is we're just going to see it disappear. And if I don't miss my guess, it's going to be pretty soon. So watch carefully now. And let's zoom in even more. All right. And let's just watch and wait until we see it go behind the moon. Kind of interesting to see how that happens, right? When you actually watch the moon passing in front of a star. It's kind of neat. Now, at the limb of the moon, there's lunar mountains. So there might be a little bit of a flicker that we might see. So we're going to see if we can see that. I'm also going to take a snapshot. Okay. I just took a snapshot. That's going to be up in the directory. It's called the Spica and Moon Occultation. There we go. After it goes, I'll say hi to everybody who's here. That's great. Really nice to see you. All right, let's get this out of the way. Okay, this, and then this. Yeah. There we go. You can just see it starting to go around, so it's probably about here. It's getting really close. Wish we could see that. If I can punch it just a little. Yeah. Try this. It's overexposed, but that's good because we want to see just a little. I can see the limb just barely here, just like you. When it comes out, of course, it's going to come out on the bright side, so that will be pretty obvious. All right, about a minute or so until this actually happens. All right, let's go. This is crazy. So when a bright star passes behind the lunar limb, there's mountains there. You might see it flicker a little bit, and that's because the starlight is passing through the ragged edge of the moon, and sometimes the light is diminished and it comes back a little and gets diminished some more as the lunar mountains start to occlude some of the starlight that we're seeing. Right, I see the limb right here, so we're up. There it goes. Look at that, just like that. Wow, so that was pretty quick. Wow, that was pretty cool. All right, well, now that that's happened, I'll come back down here and we'll put this out here. I'm going to drop this by, drop our gain down a little bit. Okay, so we'll have half the gain. There we go, so it's a little nicer to look at. Let's say hi to people. Who do we got here today? We have Tim F. Yeah, right. And Izabela, Tim beat you again. That's right. C&D Boy, hey man, how you doing? And Tiffany's with us. Hey Tiffany. I haven't talked to Mike in way too long. I really have to, and just to find out what's going on. And then we have Daisy and Zoe Amethyst with us, and Alicia is with us. Alicia Vieras. Is Darlene watching, Alicia? This was something she should be able to see. Okay, and then Jessica S is with us. And who else do we have here? Starland, hey, how you doing? Nice to see you. Adrian Tobin, how are you? I'm glad you appreciate it, Adrian. And Zoe's with us. Hi, Zoe. Let's see who else. SMA's Sky, what's up, man? Michael Galea is here. And Donald Kunzer's with us. Rocket City Astro. All right, so now we wait for a little while. As it gets darker and before the moon is scheduled to come out, that's right before Spica is scheduled to come out again, what we can do is we can look at some other objects, provided it's dark enough, you know. Sean, hey, thank you. Nice to see you. Thank you for the contribution. That's awesome. So how is everybody doing? I hope everybody's doing great. Yeah, that's right. Hey, look who's here, Isabel says. Sean. Yeah, that's very kind, Sean. Thank you, brother. As you can see, like I said, now you have a really good view of the telescope in the building. Actually, you never get to see this, so why don't I, while we're waiting for this, let's just pull this out and let me kind of give you a closer look at everything in there. So there is the telescope in the building. You can see some clouds right there. Okay, the sky is quite bright still. You know, it's not remotely dark out there, but we got a really good view and we're able to see Spica go behind the moon. It was quite nice. And so that's pretty cool. And let me bring up this view here just to show you this as well. This is a ground-based view looking up, so you can see the entire telescope. This is the guide scope. This is a smaller target scope, main guide scope, main telescope. You notice this thing sticking out of the back? That's where the camera would normally be on the telescope, but that's actually a counterweight because we have this long lens off the front of the telescope here. That long lens has got the camera on the end of it. So we have the camera on the end of the front of the telescope, and that's kind of a strange thing, but what that does is that makes our telescope 25 times faster. And so instead of shooting at the f10 photographic speed that this telescope normally comes as, we're shooting at f1.8. So it's really actually hard to get a good photograph while it's bright out. And as Izabela says, it's strange to see blue sky from the observatory. And you're right, it is. It's actually very strange. You know. So that said, I'll put this one down here. And this is usually the one I typically use a lot more. And I will put these back where they belong. I'll dock them up over here. Okay, and then this one goes right here. And then we have the ability to see all of our stuff again. All right, so looking at the Terminator of the Moon is actually pretty interesting in and of itself. There's a lot of really cool stuff happening there. Now I figure while we're here, I'll address some of the misconceptions that people have. We'll zoom in a little bit. Okay, when you look at the craters, one of the misconceptions is that all the craters are at the same depth. Well, they're not. And you'll also notice that many of the craters look like they have flat bottoms. And they do. And that doesn't mean that that's what they always had. They were carved out wells in the lunar surface. But then they were filled by molten material that was created in the initial impact that then filled in the crater. And it sought its own level. All right. And then we also have, for instance, very large impact areas. You'll notice this looks round. That's because this area here on the moon was actually struck by a very large asteroid, and it created this big giant hole. And then, of course, the impact was so fast and it had such speed that the kinetic energy, the energy of motion, was converted almost fully into heat when it struck, and thus it was vaporized. The impact was vaporized, but it went deep enough into the early moon that it actually caused lava to come to the surface and spread over the moon and fill that all in, and that's what we're seeing there. Okay, so some of the craters, when you look at them, some of them are complex craters, they're called, like this one. You can see it has these mountains in the middle. Those are that central peak, it's called. Those central peaks occur, if you think of it, a simple way to think about it is when you drop a pebble into water, it goes, right? And when it goes in the water, it goes in the water like this, and you see a central bloop go up in the air. Well, this is the bloop. This is the bloop, all right? So when we actually look right here, that central peak, that's a bloop. So that's where all the material comes rushing back toward the center and piles up and goes straight up into a higher elevation on the moon like this. We don't say it goes into the air because it's actually not the air. It's called an exosphere as opposed to an atmosphere. So that's what's really cool. That's what's really cool. Nanotech Republic asks, when will Spica be covered? Well, if you just got here, you missed it. We all saw it disappear right here. And it's going to reappear over here. I can show you exactly where that's going to be. Okay, so we'll go to the moon here. All right, and let's go to our normal time. So there's our normal time. All right, and if we accelerate the time, all right, so I'm accelerating the time now. Accelerating a little more. And then you'll see Spica come out of the limb. This is accelerating time right now. So it's 7:47, 7:50, 7:55. Okay. And here it comes. You can see the word Spica coming out. Of course, we don't see a word. And then let's just do this. Select Spica. All right. And now here it comes, and here comes Spica. So it starts coming out right around. Oh gosh, it's what is it, an hour and 15 minutes or so. So that's about what it is. So it's really cool, and we'll be here for that. If you want to hang out, you can. We can talk about the moon. I can show you some cool things about the moon. But if we look back at this, all right, let me zoom in. Okay, so Spica is coming out right here. And as soon as you see the bright thing, I'll stop it. Okay, so right there. So Spica will be right about here, and that's going to be right near these two Maria. So if we go over here, these two Maria, right, Spica will be coming out right about here. Let me just show you that again. So draw a line down through these things, right? And you'll see Spica is going to come out just above it. So draw a line down between these two things. Spica is going to come out right about here. Okay, so we'll be looking for Spica to reappear. All right, so let's. Now it's getting darker and darker out there. Our upper camera here is already going into infrared mode. And this camera here will go into infrared mode as well at some point. Pretty quickly, I would think, pretty soon. Hey, how are you? All right. All right, so hi there, Calamity Badger. He asked a question about Rupes Recta, the straight wall. Hey, Carl Becker's with us. How you doing? Sean G is with us. Let me see. Okay, we'd be able to zoom in the straight wall near the moon's terminator. Oh, this telescope, as I was mentioning, Calamity. I love that name, by the way. This telescope is actually a wide field scope. So if I show you the actual field of view that we have, this will show you right here. This is our field of view. It's literally 3 full moons across and 2 full moons tall. So to zoom in, I'll show you what happens. We zoom in, and now we're using fewer and fewer and fewer pixels to see details in here. All right. So our next telescope that we've got coming is going to have a higher focal length, and we're going to actually be able to zoom in on the moon in extreme detail, and it's going to be quite nice, quite a lot nicer. We'll be able to see the planets and everything. This telescope is meant for nebulae and wide field arrays, and that stuff is gorgeous, and we do a lot of it, as many of you know. But the telescopes all have their specialty, you know. So we're actually going to be using that telescope that we're getting. That's actually, we broke ground in Benson, Arizona already for it. It's 200 miles to the southeast of this one, out in the Benson, Arizona desert area. And so I think that what we'll see is a far better view of the moon than we have with a wide field scope like this. But we're getting there, and it's actually pretty cool. I think that we'll be able to see some beautiful, exquisite detail. We'll be able to zoom in on craters like this, for instance, and you know, like, whereas now if we try to zoom in, they're just a little bit fuzzy. That's because we're actually stretching the limits of our telescope. That's an f1.8 telescope, and the one we're getting is going to be like an f10. No, actually it's going to be running at f7, so it's going to be have more focal length, meaning we'll be able to zoom way in and see things better, more magnification. So let me see what people are asking here. SMA says, my next star 4SC is just the right focal length to get the sun and moon as much in the image as possible without cropping any of it. Yeah, that's about right. That's cool. Let's see. Just gotta check to see what folks wrote on. I don't want to miss any potential questions that you may have. You may have none. Let's see now. Carl Becker asked a really good question, actually a fascinating question that is one that I thought about for many years, and that is, how come there's so many craters on the moon but not on the Earth? The answer goes to our history. First of all, the moon doesn't have any plate tectonics. That means the moon doesn't have any earthquake zones. It doesn't have any crustal resurfacing caused by collisions between crustal plates. It doesn't have the number of volcanoes that we still have. And volcanoes resurface the Earth. Plate tectonics resurfaces the Earth. Weather resurfaces the Earth. And earthquakes resurface the Earth. And really, rain resurfaces the Earth, erosion. And so we have many craters on the Earth. In fact, if you're really interested, go to your Google Earth. Look up in Google, actually. Look up Google Earth crater overlays. And you can see the many hundreds and hundreds and hundreds of craters that have been found on the Earth that were from impacts in the past. They just found one under the Greenland ice cap. There's one in Ontario. There's the one in Arizona. The meteor crater, it's called, used to be called the Barringer meteorite crater. And the atmosphere, as Desert Dweller says, the atmosphere is actually quite a factor in weathering a lot of the craters that occurred on the Earth, the early Earth. So we had probably more craters than the moon did, but our planet was able to weather them away. And don't forget, the asteroid strike that killed the dinosaurs off the Yucatan Peninsula, well, that crater is buried under the ocean, right? And it's buried deep under the ocean. It's actually deep in the crustal plate underneath the Gulf of Mexico. And it was discovered when an oil company was searching for some potential prime land for doing offshore drilling. So it's interesting how this all works and how this happens. And I'll say it's something that we all take for granted. We see the moon, we see all the craters, not thinking that many of these craters that occurred on the moon occurred here and happened here. And there's a lot of things that are really, really interesting on the moon to look at. Again, these darker gray areas we talked about, these are the Maria, the seas, right? They're just massive asteroid strikes that flooded the moon with lava from inside. Okay, that's what this one is. That's what this is. That's why they look round. Okay, now, interestingly, when you look at these seas, they look like they're smooth. No, they're actually pockmarked with many, many craters themselves. When you zoom in, you see thousands of craters, and then craters within craters. There have been so many strikes on the moon. Now, a couple things happened. The moon went through a bombardment era called the early bombardment, and then there was a late bombardment. And this was when a series of asteroids struck both Earth and Moon in the early solar system during early formation. And I think that it's interesting to look at all the details on the moon because this is preserved in time. This this is a very important snapshot in time of our moon. I'll actually take a snapshot here. And so I've taken a snapshot, and now it's up there, and this is the image that you'll get if you want to download it and look at it and use it and do whatever you like with it. Okay, so that's our moon shot that we took just now, right? And I have a couple of Spica before it went behind the moon, and we'll take a couple as it just comes out as well. So that's pretty interesting, and the other thing is when you look at the moon, we can tell its composition by doing a spectroscopic analysis of the sediments. Sediments absorb a certain type, certain parts of the sun's radiation, and we can see the spectrum of these different regions, and we can tell what they're made of. There's a lot of titanium on the moon. There's a lot of iron. There's a lot of nickel. There's a lot of other materials, olivine and so forth, volcanic origin materials on the moon, because the moon was molten at one point, like a molten ball. And so once that started to cool, well, then it would get bombarded. And this bombardment that took place on the moon led to this distinctive look that we see, obviously. Now, interesting thing about the moon, the front face of the moon facing us, because it's locked, we only see the face of the moon. So when they ask you the question, it's a trick question, does the moon revolve on its axis? What's the answer? Who knows? Put it in the chat. Now, remember, the same face of the moon is facing us, so is the moon revolving on its axis? Okay, SMA says it does. Okay. And if it does, then what's the rotation period? How long does it take for it to go around once on its axis? Adrienne says nope. And Eliza Raquel's we're here. Eliza says, Mark, I saw you on last night. The proof is out. The new episode, Blue Lava. Oh yeah, the Blue Lava was fascinating. To be an astronomer, you also have to know a lot about geology and earth science. And so they asked me about the Blue Lava story. That was fascinating. Okay, SMA says roughly 24 hours, I think. All right. Well, I'm going to give you another clue. How long does a lunar cycle take? From the time you see it in the sky like this is first quarter, to the time it comes around. Starland, you're on to something. Starland saying once a month. And that's true. That is the period. As Rocket City Astro and Starland, I knew what you meant. And Elisha says 28 days. Okay, yes, about a month. That's why we don't have a first quarter moon at the same time every month, because it's not quite the same. Right. So yes, and so that 28-day period that the moon revolves on its axis is the time it takes the moon to go around our planet. Okay, and the reason it's facing us like that. Tidal locking is a fascinating phenomena. And, Pluto's moon Charon is tidally locked to it as well. And the Galilean satellites that are circling Jupiter are tidally locked, the inner four. All right? And how does that come about? See, what happens is when you have a large gravitational field like the Earth, and you have an object like the moon, that gets close enough, but not too close, then its rotation can be, if it had an initial rotation when it was first formed, that rotation can be affected by the larger gravity of our planet. And so, simply put, the near side of the moon feels gravity a little bit stronger than the far side of the moon, if it's close enough. And so that would tend to cause the moon to feel a difference from one side to the other of the gravity. But the added complication is that the Earth has water, and the water makes what's called a tidal bulge. And as the Earth is rotating around, the tidal bulge is getting dragged around with it. So the tidal bulge is always leading the moon as it's going around in its orbit. So the bulge is sticking out a little bit this way, not directly toward the moon, but a little bit ahead of it. So there's a little bit more mass sticking out up here. So that tends to pull on the moon a little bit more, and that caused the moon over time to slow down in its own revolving speed, because it used to revolve. And the Earth used to have a day that was only 4 hours long. The Earth spun very quickly. And then because of the interaction with the moon like that, the it's called angular velocity of the Earth, was transferred to the moon enough so that the Earth's rotational velocity slowed down. So we went from 4 hours to 12 hours to 18 hours to where we are now, 24 hours. And our day might get a little bit longer over time. And as it does so, the moon is also, because of the tidal bulge leading the Earth a little bit, the moon is getting pulled around the Earth a little bit, tiny fraction of a bit faster all the time. And that's causing the moon to sort of spiral away from the Earth a little bit more. So the Earth is actually and the moon are separating by 3 centimeters about a year. So that means that much. Every year, the moon is that much further away from the Earth. So technically, if all things stayed the same, the moon could theoretically get far enough away that it wouldn't be gravitationally bound to the Earth anymore, perhaps. But before that happens, the sun will end its existence, so that'll end that real quick. So it's pretty cool. Alicia is saying, could someone explain tidally blocked? Tidally locked, not blocked, tidally locked. I'm sorry, I misspoke there. Tidal locking has to do with that larger gravity tugging on the object with smaller gravity, but if it's close enough, then the moon's front face feels more of a gravitational pull than the back face. So it would tend to slow the moon's rotation down and cause it to orient in one direction facing us. Now, over time, theoretically, because of the fact that the Earth's rotation is slowing down because the moon is spiraling away, eventually the Earth and the moon are going to be tidally locked to each other. So the moon and the Earth will be rotating around each other at the same speed. And so that means our day is going to get a lot longer. But that's if the sun weren't to end its existence. But it's going to be long gone before the moon gets far enough away for this to happen. So tidal locking then has to do with differential gravitational tugging on the face facing the bigger planet than the side that's not. Now, also, when you look at the moon, you'll notice that the side of the moon facing us is actually the side that's actually got all the craters, and not all the craters, all the gray maria here. You see these gray seas on the moon only on the side facing us. When you go to the other side of the moon, it's all craters. And some of the highest points on the moon are on the back side. There's actually the lowest point on the moon is on the back side as well, but that's because of yet another impact. But if you think about it, when you look at the front side of the moon, it is radically different from the back side of the moon. Now the question is why? Who can venture a guess? I'll let the chat dwell on that. So the question is, why is the front side of the moon covered with all these lava seas, these gray patches of lava and welled up areas, but the other side of the moon is covered almost exclusively with craters? What's different about the side facing us than the side facing away from us? Think about that for a bit. Meanwhile, Izabela said that there are stars that are tidally locked. Yeah, that's true. See, there's a couple reasons why the moon is still a solid body and not hasn't been destroyed by Earth's gravity. Every planet has something called a Roche lobe. Okay, that's a R-O-C-H-E, Roche lobe, L-O-B-E. And the Roche lobe is the maximum size that a planet can fill before the stuff will actually leave the planet and go to some other companion. So if we had the moon much closer to our Earth, it could end up being thrust within some of the Roche lobe of the Earth, and that would actually start the moon it would cause the moon to start to disintegrate, and our moon would end up being long disintegrated a long time ago. Now, even when it was closest to us, when we only had a 4-hour day, it was still far enough away that it wasn't subject to this destruction, so it was outside of our Roche limit. Okay, so that's interesting. So the moon will never break apart because of the Earth's gravity, all right, and there's nothing to bring the moon closer. It's actually driving itself away by stealing angular momentum from our tidal bulge in our oceans. If we didn't have oceans, well, then things might be a little more static, but because of the sun and the moon, our continents also are making a continental bulge ever so slightly. So the moon might still be spiraling away, even if we didn't have oceans, but it would be a lot smaller an amount. And the moon might now still be closer to us as well, because the spiraling wouldn't have occurred for as long a time with as high a magnitude. So, next Tuesday I'm actually going to be teaching a class on the moon at a local place here in Connecticut, and we're going to be looking at craters, their depths, the types of craters, and we're going to be talking about these Maria, the seas. That's Maria, M-A-R-I-A. They're like mare, M-A-R-E, sea of, mare tranquillitate, mare tranquillitatis, mare, sea of tranquility, things like that. So it's pretty cool. So again, the question I gave you was, why is the front side of the moon so pockmarked with these gray seas, and the backside has almost none? There's only 2 small ones on the far side of the moon. So let's see who might have said something here. SMA Sky says, in fact, it changes in density the moon has, so much so it can cause issues with the navigation, if I heard correctly. Adrian says, our asteroid belt is not between Earth and the moon. That's correct. But if the moon was any closer to us, we could have a rubble moon, which is just, we'd have a small ring, like Saturn perhaps, because the moon would be destroyed by being too close to the Earth, and that differential gravity would have torn the moon's front part away from the back part and disintegrated the moon over time, and we'd have a ring, which might actually have caused lots of impacts on the Earth, which could have rendered it lifeless long term. Estimated sky, the side that faces us doesn't get as many impacts anymore unless it's side on. Well, yeah, that's sort of true, but don't forget that we were watching a lunar eclipse, 2019, and we watched the meteor strike the moon. We saw it. We were one of 5 groups on the whole planet that saw it, and it actually struck right about here. And we saw this bright flash right here. Bam! And that's actually in our stream. You can go see it. If you look it up, you'll see it. And it shows the picture shows the moon with a bright dot right here. And that's the moment of impact. Mindfork's with us. Hiya, Chris. How are you? Dark side of the moon has a huge entry hole. Actually, Adrian, the dark side doesn't have any big holes at all. Actually, it's well covered by the Lunar Reconnaissance Orbiter. We can see down to objects that are just a few 10, 20, 30 feet across. And so can you. You can go look at the Lunar Reconnaissance Orbiter Quick Map. That's QUICKMAP, Quick Map, LRO Quick Map, okay? And you'll find the moon, and you can look at the front, you can look at the back, you can see the 3D globe, you can rotate it any which way, you can zoom in and zoom in and zoom in, like unbelievably, you know? And so that's pretty cool. And Calamity, if you want to talk about seeing Rupees Recta on the straight wall, try it with the Quick Map if you haven't done that yet. Okay, so it's LRO Quick Map. Look that up in Google, and you can go check out Rupees Recta, and you can literally go down inside and look at it from below and kind of go right along the base of the wall if you want to, because it provides you with that ability to do that kind of stuff. It's really cool. I've done 2 classes on the Lunar Reconnaissance Orbiter Quick Map, and they're on our stream as well. Okay, now Starland says the near side has thinner crust than the far side. Oh yes, that's true, and that's the answer to why we see more of these seas on this side than we do on the far side. Now the question is, for Starland and everybody else, why is the near side thinner than the far side? Carl Becker says maybe from impacts on the Earth, which travel to the moon. Okay, that's actually not a bad answer at all. That undoubtedly does have something to do with this. In fact, we know that impacts on the Earth are related to why we see more of these on the front side of the moon than the back. So both Starland and Carl Becker, those are excellent statements. Izabela put the quick map up for you guys, so you can check it out. You'll get lost. You'll miss dinner. You're just gonna say, "Wow, I can't believe this." You can look up the Apollo landing sites and see. In a couple of cases, you can actually see the shadow of the flag on the moon. You can see the rover and astronaut footprints and tracks left from lunar orbit, and a lot more. Hey, Jeremy B, how you doing? Yeah, Spica went in right about here, and it's going to come out right about there. We're waiting to see it. It's getting darker now, so I'm going to increase my time here. I'll increase my gain to 100, and then I'm going to do this. Kind of go into a low light mode. Try so we can see when Spica comes out. It's gonna be a while. All right. Drop this down. All right, I'm gonna just get this. All right, 1 second here. We got a ways to go here. Okay, let me look up some data here. I'm just getting some times, guys. I can actually probably bring this down for now. Just for now, and then we'll bring it back up as we get closer to reemergence. Again, you see these two Maria here, right? The reemergence is going to be right about here. So Spica is on its way, and we can, let me go to now time. So right now Spica is right where the cross is. Okay, so right now Spica is at the terminator of the moon right here. That's where it is. Okay, because we're tracking Spica right now. This is the crosshair for our telescope. As you can see, if I bring up our crosshairs, that's kind of where we are. We're kind of looking down low, right? All right. SMA, you have clear sky right now? So right now it's 8:29 out in the observatory PM. This is out in desert, okay? And it's going to be re-emerging at around 9:11. So 11 minutes after 9, it'll be right about there. So the time now here is, let me see. Right now the time is 8:30 exactly. And as I said, this is where Spica is. This plus sign marks where Spica is behind the moon right now. So it's really at the halfway mark, and it's going to be coming out right here. Okay. Alright, so we'll come back. Wait, let me just check that one more time. Sorry. So those three craters. And those three craters. Yeah, see? So right now, Spica is just, there's those three craters to the right of that crater right there, the bottommost of the three. So right there. Spica's right there behind the moon right now. Right there, exactly. And it'll be out here in a little while. So we can watch it happen. What I'm going to do here is I'm going to move a little bit to the west. Now I'm going to try something crazy. I'm going to go to 1 second here, which is long. It's going to blow this out, so be prepared for bright view here. So there's another star out there, another star over here. So you can see there's other stars here. That's my point. And if we drop it down to a quarter of a second, let's say 62 milliseconds. Okay, then that's enough to kill our stars because the moon is so bright, right? But the sky's not dark enough yet. But we'll see Spica nonetheless. once it comes back. And we can drop this down. And I'll do that. Let's try that. Okay. That's good. Okay. All right. So if we punch it up, Spica will show there because it's brighter by far than these other two stars that were there. That's good. Eliza Raquel. Mark, did you ever catch the mouse from last week? I did, Eliza. He finally worked his way into the trap. He was trying to get into the trap. Why? He was hungry, and I put peanut butter in there. For those that don't know or weren't here, I had a mouse trap down next to me here in my office, in our production bunker here in Connecticut. And there was this clicking, and you can hear metal. It's a big metal trap, and it's a no-kill trap. And some little mouse trying to get in, and he wasn't heavy enough to do the teeter-totter thing. So it's like I felt bad. I wanted to help him. So I basically was sitting here, and every now and then you hear him going tick, 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 trying to get into the trap. And every time I'd look at where he would to try and get in the trap, he'd run away. Well, then he finally got in. After I got off the air, I went and looked, and he was actually in the trap finally. He made it. I heard a ka-dunk. So somehow he must have figured out how to use his body as leverage against the top of the teeter-totter, drop it down and walk into the trap, and he got his reward of peanut butter. And he also got freed the following day. I went and I freed him in a little forested area just a mile up the road. And I put the trap back in place here. And I'd say within a half an hour, another one was in there. And, okay, so I drove it up to the same place, let him out. And it was like the same size, probably from the same litter, so they probably met up. You know, it was a meetup, you know? So it's kind of cool. Yeah. I don't kill things if I don't have to. That's just not me. So. Oh, yes. Liza says mice love peanut butter. Oh, yes, they do. Carl Becker says he's got foggy conditions. Lights diffused. I see a star on the shadowed side. Yeah. That star you're seeing. Let's go back and look. You could be seeing this guy right here. This is a star that's... Oh, no, you're not seeing that star. Oh, wait a minute. Hold on. That's better. Okay, I had turned off the atmosphere so we could see everything. Well, you might be seeing one of these stars here. Oh, okay. You could probably... Maybe you're looking at one of these. Oh yeah, that star is only magnitude, what is it? 5.25. I don't know how dark it is where you are, Carl. Or how far away it is. This is H Virginis. It's another star. It's another 5.2 magnitude. Backing away more. I don't know how many moon widths is it away, but it depends what you're looking at. If you're looking at it with binoculars, then you could have seen these other ones. Okay, so we have the moon right here. Okay, right about there. So this is our view. This is a square represents the field of view of our telescope. Hey Sam S, I don't think I said hi to you. Sorry about that. Word of the peanut butter has spread around the world. Get it, Izabela? You made it funny. Susie Karasik. I imagine them meeting up the mice that mile away and freaking out. Susie, have you used, I think you won our binoculars, didn't you? At Contact in the Desert, did you not? And I think you've won them. Let me know if you're using them. Izabela, yes, that was a funny joke. Because we spread peanut butter on bread or toast or whatever. Oh no, we don't want them to meet up with the bear. Yeah, I have a bear that destroyed my garbage can impound area. It just ripped it to shreds. So I have a neighbor who's building a new one made of 1-inch thick wood. It's going to be quite armored. Because he reached in, he grabbed my garbage bag. I started chasing him. I said, "Give me that back! What are you doing?" And they're very timid. They don't, they don't have any cubs. Then they're more fearful. So this berry girl was just trying to get something to eat, and she made a royal mess. But she tried to leave my yard, but I have a big forested area, very, very thick undergrowth, and she couldn't pull the bag through the undergrowth, so she ate it right there next to my shed and ripped it all apart. And I'm like 20 feet taking pictures away. I was in my car. I got in the car and drove down the driveway a little bit to where the shed was. She was eating this, and I'm taking pictures and video, saying, "Man, you're saving me from having to go to the dump with this and throw it away, but you're making quite a mess I'm going to have to clean up." So, yeah. And now Izabela understands about the spreading peanut butter. Right, so going back to here, and let's go to Spica again. And to do Spica, I've got to do this now. Just a minute. Where is... I'm trying to get this... Oh, let me do that. All right. Okay. Spica. Okay. So there is Spica. Spica has moved across the lunar face now. Behind it, it's right there. There are those three craters, right? These are those three craters right here. See how they look? Looks the same that way. Okay, we got those three craters and that big one, and we we crater hop over to this little guy. So we got those three, and that big one, and we crater hop over to this little guy. And right here is where Spica is, right here now. So Spica's right there, moving its way inexorably across the face of the moon. Actually, the moon is moving across the face of Spica. Pretty cool. Oh, Susie, you won the telescope. Okay. I forgot. That's good. That's right. It's 110 degrees, actually. Minimally there. Yeah, out in the building right now. Let's see what the temperature is. Right now, out in the middle of the desert, it's 36 Celsius. That's pretty bad. Sorry about that. Oh, there's a jet. You see the jet? We had a jet cross in front of the moon, so that's preserved forever. I think you guys saw that. That was pretty cool, huh? Hey, Ray. Cosmic Ray's with us. Francis Palmer's with us. Hey, Mr. Ranger, sir. How about another picnic basket?
Not now, Yogi.
Hey, be quiet, boo-boo. Yogi, get out of here, Yogi. Did you guys see the jet that crossed right in front of the moon just now? Stuff like that happens. It's pretty cool. Francis Palmer asks, Mark, have you seen the mountains on the moon by a star occulting it? It would be interesting to know. With a higher focal length telescope, you can actually take these really nice shots of lunar occultations of stars. If you put it this way, the moon is always occulting stars, all the time. It's just that they're many times dimmer stars. It happens that this one is pretty bright. And again, we'll track where it is. We come to our, here you see this plus sign right here. That's where Spica is currently, behind the moon. Here's the moon. There's Spica. All right, so we have the, oh, sorry. Let me center on Spica. Yeah. So there is where Spica is right now. All right. So we watched it cross here, and it's gone there, and it's going to come out just ahead of these two Maria here, and come out right about here. And that puts it right about here. That's where it should reemerge. And the time for that is going to be about 9:11. It's 8:44 right now. Cosmic ray is correct. We need a grazing event where the star moves across the very limb like this of the moon, where the mountains can truly be seen, and you'll see the star blink out, come in, blink out, blink in. And that's because it's passing behind lunar mountains. And remember, a star is only ever a point of light, a point source. That's it. So, therefore, a single point source can be easily occulted. All right, let's bring this up a little bit, and then drop this down. It'll be a little bright. Now, there we go. Eliza Burkell, yeah, she was there when you won the telescope. Oh, she was 2 numbers away from winning. I'm sorry, Eliza. We're going to be running more contests here, don't worry. Thank you, Carl, for that information. Stars at 7 o'clock. It's a dark side is on the left, just off the edge. Okay. It's a slightly higher elevation. Yeah, we're about 2,000 feet out in the Sonoran Desert here, where we are with the telescope. Well, the telescope's there. I'm in Connecticut. I'm 2,600 miles away. And I'm at about 1,000 feet here. Yeah, Susie was such a ebullient winner. As we announced her as the winner, I remember her going, that's me. It's like, whoa. We all got such a big kick out of Susie. We really enjoyed meeting her. She won a Celestron telescope from us. Let me see if I can pull that up. Yeah, so that'll end up showing a star when it's time. Well, the thing is, it's going to show anyway, because it was actually pretty bright. Let's see if we did this now. That's going to be pretty bright. I'll drop this down a little. Yeah, I was just telling you guys before that when you look at the these settings on the telescope, I'll just run you through them again just so you know. This here is the telescope control up there. This is the telescope computer. This is the telescope in the building. So is this. This is, well, you know who that is. And then this is the camera control cluster over here. Okay. And the one thing that's really important is this field right here. This is the exposure. And the other one that's really important is the gain right here. This is how sensitive we're making the sensor, and this is how long we're exposing that sensitive sensor. And you trade off on those numbers to try and get the best look, the best value. And that's what we got. This down here, these are the focusing sections. So this is the focus segment right here. We can do some little image processing here, and there's more fields down below here. But once you set those in play, like right now, I don't have a flat file in here, but if I put it in, we're automatically going to start using a flat. But that isn't going to make much sense unless we're actually taking photographs. Okay, so yeah, so we come back and we see Spica is right there. Right there. Hold on, let me center up on Spica again. There we go. There we go. Yeah, okay, I see what it's doing. Hold on a sec. Alright. So Spica is selected and it's centered. And so it's centered right there. And if we increase the speed and go into the future here a little bit, you can see right where Spica is going to come out. So watch the plus sign. All right, and then right here, Spica comes out. All right, and so that's going to be at around 11 minutes after 9. So we can go back to our regularly scheduled time now. This is live time now. So that's pretty cool. And I can actually move this over a little bit so we can have the moon and Spica, the moon in the same view with us. Hey, Michael Hedrick, what's happening? Well, Michael, you missed Spica going behind the moon at the beginning, but you'll catch it on the way out because it's right where that plus sign is now behind the moon. Okay, it's by that crater, and if we look, that crater corresponds, if we zip back out a little bit here, okay, you'll see these three craters here, which are these three craters here. And then you'll see this crater right there. Okay, that crater right there is this crater right here. So Spica right now is just a little bit to the right of that crater right here. So Spica is behind the moon right there. Pretty cool. So here is our star view. The moon is right here. This is our all sky cam. All right, and we're currently looking at, that's Arcturus right there, and then down here is the moon, and Virgo's down here as well. And so we're unable to see Spica because it's behind the moon. All right. Susie says, I'd love to get your presentations to schools, but there are geographic issues. Well, that's true, I guess. I mean, not everybody's going to be around when we're streaming, but all of our streams are on the channel, and people could play our streams in a classroom, and I could come in live to the classroom via Zoom or some other thing and talk to students live. That's something that I've actually done a bit of. With our friend Dave Schmidt, I talked to his class in Bangkok that way, but it was actually live because they're exactly 12 hours ahead. So when it was 9 p.m. here, it was 9 a.m. there, right at the time when his class was coming in. So I had a chance to address his class that way. It was kind of fun. Yeah, Cosmic Ray says, SkyTour is on our channel, right? And if you know where that is, it's right here. You go to skytourlive.org right there. skytourlive.org, and in the upper left on that location, you go to either SkyTour live stream on the left, or to the Patreon on the right if you want to help us out. We are a non-profit organization. I have yet to take a dime from this organization at all. I am interested in getting the knowledge out, not interested in getting the money out. We are very interested in furthering the science, very interested in getting our other sites up and running and adding new sites. We have a mobile observatory that we have in the works right now that we're planning. That's going to wait for some support. And the mobile observatory will be able to take all around the country and show people in very light polluted cities that the night sky over their head is not as invisible as they think with the right equipment. So I think that's pretty cool. Michael Hedrick asks, Mark, do we need to worry about space junk hitting Earth after the recent SpaceX mishap with Starlink? Now that mishap was an icy burn where they actually had a leak of some kind that caused fuel, most likely liquid oxygen, to escape from some piping and form ice, which you saw breaking off and instantly vaporizing in the exhaust. Very dramatic looking. So bottom line is that is something that I think is nothing to worry about, because that was just ice. As far as the Starlink satellites, some of them probably won't get to orbit, but there's others that might be boostable. I'm not sure if they've updated that yet to tell us whether they can boost those satellites. They do have fuel on board for such a boost, because they're going to need that. Yeah. And that fuel is required to actually boost them to a higher orbit, yeah. Hey Fantasy, what's up? And I did start before sunset, I did indeed, and we had blue sky, so people got to see the telescope under blue sky and in color. Right now they're seeing it in black and white. So with Spica right now, the Alpha Virginis, the bright star in the constellation of Virgo the Virgin, is right under that plus sign right there. Okay, so if we get closer, you can see that it is just past it's just past this crater here. Okay, and that crater is that crater there. All right, so it's just down in here now. So that's pretty cool. Nice. Actually, it's right here, sorry. Yep. Very nice. Yeah, so it's right there. And if you were here earlier, you saw an aircraft, a jet, go right over this part of the moon. You saw the distinct shape of the aircraft. Looked like a 737-800, actually. I'm going to guess southwest. Although it could have been not Allegheny, what was the other? Allegiance. Allegiant Air. Could have been an Allegiant Air out of Sky Harbor as well. Okay, 8:58. It's going to be just a little bit of time here, and by 9:11, it's going to be over here and coming out. Remember what I said? If we go into looking ahead mode here, this is where it's going. Okay, and so I'll slow it down. So, and there it is. It's going to be coming out right there. And if you see, this is, if we zoom out a little bit, it's the bottom of this other area right here, this Maria, which is this one right here. All right, and there's kind of a bright area there, and that's this bright area right there. It's going to come out just above it. If you turn this the way it is, it's going to end up becoming like a triangle to that area right there, and that means it's going to be a triangle to this area right here. So it's probably going to be right about there. So it'll be right there. That's where I'm guessing it's going to be. And we only have a few minutes until it comes out. So let's go back to now time. Here we are. This is kind of cool, you know, to kind of follow this through. Hello, Cynthia Clavey. How are you? Sorry that it's behind clouds and treetops for you, Cynthia, but I'm glad that you could join us here and watch and see it happen. I don't know if you saw it with us when we saw it go behind the moon. That happened earlier, obviously, at 7:48, desert time. And it'll be coming out right here, or right here, right there. And we'll zoom in preparation for that. Let's see if we can do a little something here. Focusing here. What if we do that? Okay, so the limb is a little better now. So it's going to be coming out right about there. And if we do this and pump up this brightness a little bit, that'll help us see. It's 9:01 right now. We have a few minutes before Spica should reemerge. Okay. Should be able to see it like this when it comes out. We will look for the reacquisition of Spica as soon as it comes comes out from behind the moon here. It's going to be right there. I want to take a moment here to share with you a discovery made by Izabela. Yes, Izabela, talking about you. In looking at our previous data and then looking at previous images of the same location from 1973, 1986, she discovered that there is a star in a particular location, which we'll share when, it's not secret or anything. In fact, the more eyes, the better. And this star, it looks like it stays in place in 1973 and in 1986, but in 2015, it has moved significantly from its previous position. Now, from 1973 to 1986, that's more than 10 years. And from 86 to 2015, obviously that's more than 20 years. Okay? But the bottom line is it should have moved a little bit between 73 and 86, at least noticeably. So it's weird how you see these stars and they're in the same spot, and then just a short time later the star is there, in 2015. Very strange. And that's not the only thing she found. She also found stars that are outright missing. And this brings up something else, which is kind of a thought process in stellar evolution, that maybe there's some type of situation where a particular kind of white dwarf can continue to collapse if it gains mass, and maybe go to a neutron star, and then if it continues gaining mass, go straight to a black hole. So I think that this is something that other astronomers are also looking at, and I believe that this could be the reason why some of these stars literally exist. They wink out of existence. I remember Daryl talking about this at one point as well, and there's several kinds of white dwarfs. There's a carbon-oxygen white dwarf. That's what our sun will be. But more massive stars that don't go supernova but go into like a white dwarf stage when they end, those can make magnesium and neon and oxygen. So they're called, magnesium, neon, oxygen white dwarfs. And these white dwarfs are possibly these progenitors for this strange behavior. Okay. So here is that second thing. I know the angle is a little bit different as we're talking about here, but you see right now, Spica is right here. It is literally just above that bright object, the bright area. So it's right about here. It's right there. So we're almost to the edge right now, and it is 9:06 out there. So I wonder if we'll be able to leave this right here and watch it come out here and watch it come out there at the same time. That'd be kind of cool. You can zoom in a little more too. Uh-oh. I gotta select Spica again. I managed to deselect it by accident. That's because I moved it with the moon. Yeah, that's the center. The plus sign is the center of the frame, but if you've got a selection centered, then the plus sign is where the selection is. You can see it moving in real time here, and it's actually doing the same thing behind here. And I'm just gonna back out of this a little bit. keep the limb in view. Oh, I just did it again. Sorry about that. All right. All right, now we'll come here. Let's pull this back in a little more. Let me just try. Okay, that's a little better. That's good. Okay, it's Dino 8, so 3 more minutes, and we should see Spica reemerging. Okay, so let me prepare for that. Let's bring this up. Oh, look at that. There it is. We got it right there. Look, guys. Here it is. Look what's coming out, baby. Right there. We captured Spica coming out. I'll take a snapshot. Okay. Beautiful. There's Spica reemerging from the moon. Look at that, guys. How nice is that? The timing was off a little bit, but we caught it. It was literally just coming out as we did that. Let's see if I drop it back down. If we can still see it from where I wanted to before. I think we can. Yeah, there it is. I will take another snapshot of that. There it is right there. You can see it. And I'm going to increase this a little bit. Get another snapshot. Well, there you go. That was wonderful. So you spent tonight looking at a stellar occultation by the moon. Pretty cool. Total time of the occultation was from 7:48 Mountain Standard Time till 9:08 Mountain Standard Time. Let's see. It didn't match Stellarium. So Stellarium was off a little bit. That's alright. I was prepared. That's why I wanted to do the 2 views. So what do you think of that, guys? Was that exciting? Interesting? Mr. Django, how you doing? That's Steven Smet out in Belgium. How you doing, Steven? Catherine Messick, hello. How are you? You saw my thank you note to you for joining our Patreon. Thank you so much. I'm going to add you to our Patreon list. I haven't yet. I will do that though. Actually, I'll do it after the stream. Very cool. All right, well, it's dark out there now. Let's see now. That was a beautiful sight. So we managed to capture that, and so we're looking at this one spot in the sky. The moon is getting pretty low in the sky, not low, but getting fairly low. And we now have, just for fun, we're gonna just look at one more thing. And then we'll call it. This was not meant to be a very long stream, but long enough for us to see this. So I'm gonna take us to our 1 second normal setting, and that's way too bright for the moon. All right, But if I do this, there you go. So that's way too bright, as you can see. And we're going to bring our brightness down to fit the width of our shot in. So that's what we got. Looks like we have some high clouds coming through. We do, yeah. Let's see if we can see them. Oh yeah, there they are. We have high clouds passing over the moon. So what we're going to do now is we're going to go down to Antares, which is down here, actually. Can't see it with the moon in the way too well. That's possible. It's over there. There's Sagittarius right here. Yeah, okay. So what we'll do is very quickly capture one other object before we call it a night, because why not? So we're going to go here and check this out. This is a globular cluster next to Antares. You watch the telescope moving more toward the center here. Let's go into low light mode. Oh, and I gotta set the gain back. There we go. And there it is. Yep. Okay. So this is a beautiful globular cluster. That is a Starlink satellite. And let's bring this down and head east a little bit. Isabella, thank you for putting up the location of the pics. All right, let's center this up. There we go. All right, so what's happening is now we're going to search for a guide star. And this is a beautiful globular cluster. A globular cluster is basically like an exploding snowball of stars. Okay, this one is, as far as distance, this one is 7,176 light years away. So you're seeing it as it was 7,000 years ago, which is really interesting. And just to this side of it over here is the red star Antares. Let's do a quick 15-second shot of this, and then you can see the rest of what we do. So we don't just do live shots like we did with the moon. We also do shots like this, where we actually stack and show you these objects. Now I went into deep sky mode here, so deep sky mode is gonna, this is our low light mode, and in this next image there's our deep sky mode. All right, and we will balance all our curves. You see red, green, and blue curves under here. This white one is the average curve. I'm going to kind of zoom in on these curves, and I'm gonna scroll over to them because they're a little bit off right now. So now you can see how this white curve is the average of all three of these. And what we do is we pull this dark level up till just to the left of the peak, and that's about the darkest we get. And it looks blue because the moon is affecting it. It's actually not that far away, but I can do this, and that'll get rid of some of the noise. I can also get rid of more noise by coming in here and doing color noise reduction. Watch the screen. Watch this. Boom. Right away, we get an immediately better picture. Okay. Now what I'll do is color correct to get rid of that blue haze, that blue cast. So the blue is being removed, and now we have a black sky as if the moon isn't in the sky. That's just a beautiful thing. I have to, I did focusing earlier. Let's go see if I need to do it again. It looks like I could use it. Why don't we try that? We'll try the focus. So I'm going to come out of this, go back to our low light mode so I can focus. Alright, now we go up here. There we are. Now I'm going to bring up our, well, I'm actually taking us out of focus here. Alright. Let's make sure we can get enough stars to focus. Yeah, we got plenty. Okay, and we're a little out of focus. That's good. So then I'm going to tell it to go through a focus run, and it's going to start focusing and measuring the size of the star images inside each of those yellow squares and get the average diameter, and they need to be small, so the smallest one wins. So that smallest one will be at the bottom of a curve that's being generated right here. As you see, a curve generated here. That's cool. That was neat. So we got to see a nice occultation and a beautiful globular cluster. So the second telescope will be 200 miles southeast of this one in Benson, Arizona. This one's in the Sonoran Desert, west of Phoenix by like 75 or so miles, maybe more. And the Benson one will be this real deep sky telescope where we're going to be able to look deeply at objects. In fact, when we look at something like this, the size of the field might be only about this big. And we're going to be able to focus really, really deeply on things like the moon, like the planets, like objects like this. And we're going to be able to see them crystal clear because, again, this field is 3 full moons across by 2 full moons tall. Here's our curve forming right there. You're going to see a line show up right about there. There it is. And we'll say I could leave it going and let it do the rest, but it's got a focus point. So we'll say go to best focus and we'll abort this. Now it's going to run through all the settings again and take us back to our best focus position. Here we are. We let it stabilize. Now, when we get out of this, these stars are beautiful pinpoints. So what we're going to do is do another, we'll do 20 seconds now, 20 seconds, and get out of our low light mode and go into deep sky mode, which always means bringing up our stack screen right here. And so that's what we saw before. Nice and focused. And so we'll clear this and see what the first one looks like. It's going to look better than that did, if you like that. And so what we get is this. Right, beautiful. And we will again color balance. Right, and we will do a little processing. It's going to be a little bright, and we can take that down because there's the peak of our curve. On the average curve, we want to take the dark level, how dark space is, and move that up right to almost at the peak. And that's as dark as it gets. Color correct again. And by doing that, you'll notice that I move this line and this line close to each other. The closer we move them, the more detail we might see squeezed out. Okay, the problem is that we also get more noise. You see more noise, like when I do this. See how all this other noise in here? This red you're seeing here around here, that red is a couple things. First of all, it's still got a bit of the sunset light. A little sunset light is still happening. But that's also, there's nebula in there that's red. But with the moon out, we aren't really able to capture that as well. So there we go. So this is now probably with the first quarter moon, not considered a bad image at all. So I'm going to come up here. I'm going to change this to Measure 4, M4, and it's a GC, a globular cluster. Now, for those of you that are interested in getting our app, we're still working on getting that. And Izabela, by the way, I have not heard from the people that we should be hearing from on that. So I'm going to have to send another email to them. And I see Fairy May with us. Hey, Fairy May, how are you? Thank you for coming and checking us out. Please subscribe. You know, everything is free. We don't charge for anything. If you want to subscribe to a Patreon, you can. But it's free. Otherwise, you can join us and hang out with us like this. Listen to some cool music. Listen to some cool banter. Daryl Mason's usually with me, but he's taking the night off tonight. And we always have a family of sky tourers here who are just really, really enjoying the night. This might be nebula here that we're looking at. Some of it. I have to be careful because the moon can induce some weird things. But let's zoom in now, and this should be really beautifully focused stars. Oh, look at that. Oh, yeah. Measure for, yep. Absolutely beautiful. Okay. So this is Measure 4, globular cluster, and this globular cluster is in the constellation of Scorpius. It's beautiful. Very good. All right, let's do it this way. Yep, very nice. Now we do have some high clouds tonight, as we saw zipping through our moon image. There they are. They're in Scorpius now. They're down here, ruining our view. But that's okay. We got through it, guys. We actually got to see the night sky, and we got to see the moon pass in front of Spica, Alpha Virginis, the brightest star in Virgo. There's the summer Milky Way rising. Trust me, we've got a lot of summer observing to do moving forward. I'm going to save this as it is because we're getting some clouds in here. Well, there you go. Well, I hope you guys enjoyed this. There's not much sense in going any further because we've got some clouds moving in. But we did get to see the occultation. It went very well. We saw it go behind the moon, and then we saw it come out. I think that's pretty cool. Cosmic Ray is saying we have to do a set of Pluto images. Yeah, I think you're right, Ray. I wanted to do that. We can recreate Clyde Tombaugh's discovery. I've told this story before, but I'll say it again quick. I met Clyde Tombaugh, who's the guy that discovered Pluto, and I sat with him on a grassy knoll in Vermont one time, and we were both there for an astronomy conference. And he was such an incredible, unassuming guy. He wasn't a professional astronomer. He was just a guy who worked at the observatory on the telescope, and he discovered Pluto. Now you think about it, okay? I'm gonna say this and embarrass her. Izabela's not a professional astronomer, but you know what she is? She is fascinated and looks to try to make discoveries, and she has made some discoveries with our data. So show her some love, guys. Izabela Melamed. She is, and she's over in Bulgaria. Okay, she's as far from SkyTour telescopes as you can imagine. So I really think that that's what can happen. So when we get the app available to everybody, we'll be able to actually show you all kinds of things that you can do with this app, and it's really quite nice. Let me see if I can bring it up and show you real quick, because I think I can. Yeah, there it is. All right, so let me see if I can show it. There we go. Okay, so here's what I'm gonna do. I'm going to, while we're doing this here on the screen, you can watch that. Meanwhile, I am going to find a window. I'll add it. I'm going to add a window source. I'm going to capture a window, and that window is going to be a new window, and it's going to be STLS Stargazer Companion. That's what this is called. Alright, so we're going to add that source, and now we're going to pick the window. There it is. Alright. Okay. So here is the Stargazer Companion. These are objects we've taken pictures of. And you notice the number here. That's the number of objects that we've captured. 1,770 of them. Okay? And I'll tell you how it works. And Izabela, I did ask Izabela to join me tonight on this, but she wasn't ready, and that's okay. She's done it before. Okay? And this is really, really a good app. Right, so you can scroll through and see every observation we've made for all the way since in 2021. Right, it's 2024. And what you can do, a number of things. Okay, first of all, you have these little columns. Now, this is the PC version. On the iPhone, it's a little bit differently. Or on the Android, it's the same as the iPhone. But and on the Mac, it'll be the same as this, I believe. But you can do it as a table format. Okay, and go through this way, and you see lots of data about the observation. All right. You can also look this up. Object types. Planetary nebula. Look at this, and look what you see. Here, well, here's one we took, the Helix Nebula. And then you say, oh, well, show me all images of planetary nebula you've ever taken. Click it, and boom. You know, you get this. Now, you're not quite seeing the full thing here, and I think that's because you're getting a little bit cut off, but it's fine because I can actually maybe change that a little bit. Not sure. Okay. All right, let's try this. No, okay. I don't know why he's doing that, but it's okay. It doesn't matter because that's not a fault of the application. It's a fault of the broadcast software that I'm trying to show this. We're missing we're missing what's below here in this box from the rest of these guys a little bit anyway. But see, here's all the planetary nebula we've taken pictures of throughout time. All of them. And so you can also do this. You could actually search for different objects, right? For instance, if you want to find, for instance, the Veil Nebula, you just look up Veil. Oh wait, it says no items. I think I have to clear that search. Type of object. Oh, yeah, of course. I got to go back to the gallery. See, even me. All right. So then you want the Veil Nebula. This is the supernova rim. You say Veil. And here they are. All the pictures of the Veil Nebula we've taken. Alright. We can look up Eastern Veil, Central Veil. And if you want to filter on other things, okay, let's get rid of that and come back to this. We could also filter on all these different things. What date? What time? What object name? Okay. What type of object? We already saw that. What constellation? How about this? How about everything we've taken in the constellation of Monoceros? Okay. Hit enter. Boom. There you go. Everything we've ever taken in Monoceros, which is the constellation to the left of Orion, which is to the east. All right. So every one of them, we got the Rosette, we've got Hubble's Variable Nebula, we got the Christmas Tree Cluster, all that stuff. Look at that, huh? And it's not browser dependent. It'll work on any browser. At least I've found it works on Explorer, it works on Edge, it works on Firefox, it works on Bravo, it works on Chrome. So it's not a problem. You know? So yeah, so that's this. And then if you want to say, oh, I'm done with that search, you click that off, and now you go back to all the data. Now, say you want to look up, oh, I don't know, maybe the Andromeda galaxy. So you say Andromeda. All right, right away, the Andromeda galaxy shows up. Holy cow, every one of them we've ever taken. Now, if there's other objects in Andromeda, then it might look up objects in the constellation as well. But check this out. Here's a really pretty view, right? We click on it. We get this detail, and this detail tells us everything about it. And from here, you can actually download the full-size image. You can download the actual astronomical file format, which is the FITS file, it's called. And you see a description about it. You also can click on this picture, and wham, check it out. You can see this gorgeous shot just like that. So it gives you all kinds of options, and then to close it, you go hit the X up here. Now, for all this amazing goodness, all right, and this incredible application, we currently don't have any pricing set for it. In fact, we may not have pricing at all. We might just offer it for nothing, and we'd very much like to. And I can tell you this, what you're looking at here, everything you're looking at, this is all due to the hard work of Izabela, and she's in the chat right now. So you wanted to have, many of you asked for ways to search the data. Well, here it is, courtesy of Izabela Melamed. So please thank her, show her some love, because man, that girl got skills. I was a programmer for many years. I did database programming as well. I've always wanted to do this, and so I just never could get to it with my timing. So the fact that she did it, I was just dumbfounded, and I was just blown away. So happy that she was able to do that right there. That is just beautiful right there. Okay. So another way to get in here is to look at the calendar. Here's the calendar for July 2024. What have we done so far? Well, here's what we've done. Oh, we looked at the Black Eye Galaxy. What's that? Well, click on it, and it takes you right to that observation. At least it was supposed to. I don't know what happened there. Every time I went to an observation there, it actually did it. So, Trifid Nebula. Oh, I see. It was down here. My mistake. It takes you to the day. That's right. And then you got to click on it. So M64, the Black Eye Galaxy we're looking at. Well, there you go. And then you can click on it as regular and say, wow, let's zoom in. Check that out. And you can actually see these things. So once this is available, you'll be told where you can download it. And as I said, I'm hopeful that we don't have to charge for it. It depends what they're going to ask me to provide up front for money. We don't think that it's going to be a very bad thing. So I think it'll be okay. And if you want to know about the app, I wrote up a little something about the app here. Okay. And so again, so there's many different ways to go through the data. The gallery's kind of the most fun. All right. And you can just type what you want to see. If you don't know what you want to see, you can go to the object types. Okay. And pick what you want. Like DN. What's DN? Oh, dark nebula. And here's what dark nebula are. Again, Izabela did these write-ups for us. That's fantastic. And then she would ask me, what do you think? And I'd say, well, can you make it so we can just click on the button to see all the dark nebula? And she says, oh, yeah. And so she did that. So, it was kind of cool. She did the lion's share of the work. And Daryl and I and her were just testing it. Horsehead Nebula. Remember the Horsehead in Orion? Look at this. Beautiful. Absolutely beautiful. So there's every object at your fingertips, and this is cool. And boy, oh boy, wouldn't it be great if I could just categorize every single observation in SkyTour livestream on the YouTube channel? That would be so cool. This would be a massive database full of detailed data, and across multiple telescopes, because we're using more telescopes than just this one. At that time, And so after the Benson scope goes in, that's going to end up in here. And then on the East Coast here where I am, we're doing another observatory, which is a solar telescope. I already have it in there in the closet right next to me. And the solar telescope will be used for looking at the prominences and solar flares, sunspot groups, and it's going to really be a well-rounded methodology to keep me from getting any sleep whatsoever. So there you go. That's this. I hope that you enjoyed that, seeing that, because I really enjoyed showing it to you. And now what we'll do is come in here. I know we have some clouds, like I said. We'll save it one more time, and then we will save it exactly as seen. Oh, and this and the Spica occultation, they will be in the database in a very short order. Michael Hedrick says, Mark, really quick, please tell me how Patreon works. Do you register credit cards? Is it auto currency conversion? When you subscribe to a particular tier, I've never done it, so I don't know. But maybe someone who has can tell you how it goes, because actually I don't know. I'm so sorry. Yeah, but and we have $3, $5, $10, $25, $50, $100, $200 tiers. And believe it or not, we have a few people at each of those tiers. It's absolutely amazing. And that's basically what's keeping us going, basically, because at each of these sites we have the internet to pay for, and it's all Starlink, and Starlink costs $120 a month. So we have 120 in Sonoran, 120 in Benson, and I'm taking care of the East Coast. I'm not going to ask SkyTour to pay because I've already got it covered. So I'm not going to get free internet off of all of you, contributing to the Patreon. That's not what it's for. So I don't feel right doing that. However, I will, in the future, if we have new sites, I will cover those sites. Oh boy, I'll tell you guys, this is a great night. I want to thank you guys for coming. Michael, I'm sorry I didn't have the full answer there. And Mr. Django just answered a question. Yes, its currencies converted, taxes are added. Okay. Thank you much. All right, guys, listen, I had a great time with you tonight. Thank you so much for joining us tonight and hanging out. I really enjoyed watching the occultation with all of you. It was a great deal of fun. But for now, it's time to say goodnight, and I will see you guys another night. Tomorrow's a busy day for me. SkyTour Radio is probably not going to happen tomorrow, so we're going to have a replay, and that's from 6 to 8 p.m. Eastern time in the U.S. That's our weekly astronomy show that we do, but and that's okay. At any case, so you guys have a good night, and I am gonna just say, wow, I'm going 10-7. All right, guys, you have a good night, and we will talk soon. And before I go, I just want to make sure that I didn't miss anybody's questions. You're welcome, Catherine. Thank you so much for coming. Thank you all. Matty Waddy, thanks, man. Good to see you. I may have missed some questions. You know what, though? If I miss questions, don't think it's all lost. Just go here. Go to skytourlive.org. Go to the Contact Us, and I get those questions, okay? They go to me. They go to Marianne. They go to Tara. And if I miss a question, trust me, Marianne's going to say, hey, will you go to your email? Someone's asking you a question. She does it all the time. So we're good. So do that. Go here, skytourlive.org. And if you want to contact me directly for something, if you want to have me look at imagery or something, you can go here. My email is mufonanalyst@gmail.com. All right. I've had that email for years. That's why it's not mufonanalyst 1 or 2 or 25. It's the original one, mufonanalyst@gmail.com. And we I'll answer all the questions that you send, or if you've got any imagery or photos you want me to analyze for you. Okay. So that's what I do. So you guys have a good night, and I will see you a little bit later. Oof, what a good night. Thank you guys. We'll see you later. Bye bye.